Hello and welcome to this part of the basic concept that will be introduced in this Shoulder Biomechanics course to help you understand everything later on. This topic is very important because it introduces a concept of how we move, and it's not related to shoulder muscles only. When any muscle contracts, it determines the final movement that occurs around the joint. Let's clarify with this simple illustration. For example, let's consider this red line as a muscle and the two black boxes are bones that this muscle is attached to. The end result when this muscle contracts and shortens can be one of three possibilities. First, the distal part would contract and shorten toward the direction of the proximal part, which will lead to the distal bone moving in the direction of contraction. In this example, it moves upward toward the proximal bone. The second possibility is that the muscle moves and shortens from proximal to distal, which will lead to the opposite movement, where the proximal bone will move. In this figure, it will be in the downward direction toward the distal bone. The third possibility, the muscle would contract and shorten from both sides, which will lead to the shortening of the muscle in both directions, and both bones will move and get closer to each other. Okay, from this, we can conclude the following. Any muscle that has an origin and insertion can move the bone that it originates from towards the insertion bone. Alternatively, it can move the bone that is inserted into towards the origin bone. Lastly, it can move both bones towards each other. Put this practically with a brief example of the hamstring muscles. These muscles have different actions depending on the way they contract. The hamstring can flex the knee and posterior tilt the pelvis. Now if you look closely, observe how the muscle leads to knee flexion. It happens when the hamstring contracts from the insertion toward the origin. When it contracts from down to up, the distal attachment will follow the direction of contraction, leading to the bending of the knee as the leg moves upward and backward. On the other hand, to posterior tilt the pelvis, the muscle does the opposite. It contracts from the origin to insertion, causing the shortening of the muscle in the downward direction from origin to insertion. This makes the proximal attachment move and follow this movement, leading to the posterior pelvic tilt. So you understood that the different actions of a muscle depend on how the muscle works. Did it contract from origin to the direction of insertion or from insertion to origin? Or can it contract for both directions, leading to knee flexion and posterior pelvic tilt at the same time? Now, from these facts I have just told you, you might wonder what controls the end result. What controls how the muscle acts and forces it to work from distal to proximal only, or proximal to distal, or both? Well, actually, what happens is that the brain can control the movement of the muscle in this way. When our brain gives an order to a muscle to contract, it will always contract from both directions. Simply put, it will contract and shorten from distal to proximal and proximal to distal. So in normal circumstances, if the brain gives an order to the hamstring muscle to contract, it should flex the knee and posteriorly tilt the pelvis at the same time. Now here comes a big question that most of you might ask. Then why or how can we control our movements and the end result can be knee flexion only or posterior pelvic tilt only? Many of you might say that I can control which part of my body moves. I can move my knees without my pelvis moving, or my pelvis moves without knee movement. This is true, of course, but not by controlling the direction of contraction of a muscle. Our brain, at the same time it gives an order for a muscle to contract, can give another order to contract other muscles that help resist unwanted action. For example, if you want to bend your knees without your pelvis moving, other muscles will come into play to counteract the pelvic movement. So at the same time the brain gives an order to the hamstring muscles to bend the knee, the hamstring by mistake will lead to posterior pelvic tilt. But I don't want the pelvis to move. Therefore, the brain will give another order to the back muscles that act with anterior pelvic tilt to resist the posterior pelvic tilt that was about to happen with the hamstrings. By doing this, the end result would be bending of the knee without any pelvic movement because we cancel the movement with other muscles. Again, we have a muscle that performs two actions at the same time, which is the hamstrings that perform knee flexion plus posterior pelvic tilt. We want to flex our knees only without moving our pelvis downward with a posterior pelvic tilt. So what do? At the same time the hamstring contracts, we have to contract the back muscles, which will resist the action of the hamstring on the pelvis and cancel it. As a result, there will be knee flexion only with no pelvic movement. Okay, so now understand how the muscles interact with each other to perform the final smooth movement that we actually do. From the previous topic, we can conclude that any muscle can perform different actions on different body parts, depending on which part we allow to move and which part we resist moving. For example, we can bend the knee and resist the pelvis, or move the pelvis and resist the knee. Therefore, we now realize that we can perform different actions. So in summary, we can conclude two things. First, any muscle, when given an order from the brain, will react by contracting from both sides, the origin side and insertion side. The presence of another muscle that resists the movement on one side determines the end result, allowing movement on one side only. Second, we now understand the flexibility of achieving different end results. This can be the movement of the muscle and shortening of its fibers from the distal to proximal direction, or from the proximal to distal direction, or both. Each scenario will lead to a completely different movement. I thank you for being with me in this course. If you have any questions, please don't hesitate to send them to us. Thank you again, and see you in the next chapter.